All right, class, so today we're going to be taking a look at chapter 9, which is all about graphing different types of functions. And we've seen a lot of functions as we've worked through this class. We started with lines, right? And now we're working on parabolas. So sections 9.2 to 9.3, that's going to be all about graphing quadratic functions and then some applications of that. So let's remind ourselves what a function is. So a function is any line that passes the vertical, is any graph that passes the vertical line test, right? So that means that each x value has a unique y value, okay? And when I talked about this in class, our example was a vending machine. So if you need a little bit of a refresher, I'd go back to chapter 3. So we're going to be looking at quadratic functions. And quadratic functions are the form f of x equals ax squared plus bx plus c. Okay? And that means a, b, and c are the coefficients on our variable terms where c is the constant. And the graph of any function that takes on this form is going to be a parabola. And all parabolas have a vertical axis of symmetry. Friendly reminder that the domain of a relation is the set of all possible x values. We also call those our independent variables. And our range is the set of all possible y values. We call that our dependent variable. If you can remember from in class, I would do a little bit of an interpretive dance where I've got my x-axis and my y-axis. I'm definitely doing that while sitting here and recording. So let's take a look at the simplest parabola, and this is going to be the squaring function. So this is where I just have x squared. So my a value is 1, but my b value is 0, and my c value is 0 as well. Okay? So let's take a note of this. So it has an axis of symmetry right here at the y-axis. Okay? Its vertex, that's where it changes directions. See how it's going down and then it goes back up. That is at the point 0, 0. Okay, and what's really nice about parabolas is they are symmetric. So if I take negative 2 and I square it, I get, sorry guys, I get 4. If I take negative 1 and I square it, I get 1. If I take 0 squared, I get 0. If I take 1 squared, I get 1. 2 squared, I get 4, etc. So here we can see that our domain, all possible x values, goes from negative infinity to positive infinity, and our range, which is all possible y values, starts from 0, but 0 is included, that's why we use a bracket, and goes all the way to positive infinity. Now these aren't the only types of parabolas we're going to encounter over the course of this chapter. So it is possible to have a vertical shift of a parabola, and that's when I take my function f of x squared and I add some constant, okay? That means my graph is going to be shifted k units up, or if it was minus k, it'd be k units down along the y-axis. So for example, why don't we graph f of x equals x squared minus 2? And you'll see in the folder that there is a chapter 9 PowerPoint note sheet, so you can go along and graph these with me as well. All right, so now let's go ahead and graph the following function. So at y equals x squared minus 2. So the first thing I need to do is pick out some x values. So let's take x and our y. Let's let x equal negative 2, negative 1, 0, and 1 and 2. Remembering that this is going to be symmetrical across the y-axis. So let's go ahead and substitute. So if I take negative 2 squared minus 2, I'm going to get 4 minus 2 which is just 2. Okay, now let's try for negative 1. Let me plot this point first. So I have x is negative 2 and y is 2. There we go. So now let's plug in when x is negative 1. If x is negative 1, that gives me negative 1 squared minus 2 that's going to leave me with 1 minus 2, which is going to give us a negative 1. So I go to when x is negative 1, y is also negative 1. We plot that point. All right, let's talk through a few more. So if I have when x is 0, 0 squared is 0, minus 2 is going to give me a negative 2. So let's plot that point when x is 0, y is negative 2. Now I know this is going to be symmetrical, so that means when x is 1, it's going to be y is negative 1, and when x is 2, y is 2. So let's go ahead and plot those points. And then we can draw in our parabola, seeing that the point when x is 0 and y is negative 2 is our vertex. Now, if we can have graphs that shift vertically, we can also have graphs that shift horizontally. So horizontal shift of a parabola is when I have a function f of x of the form in parentheses x minus h squared, okay? This is going to have the same shape as the squaring function, except we're shifting it to the right, in this case, h spaces. Now that might seem counterintuitive, right? X minus h, and it shifts in the positive direction, right? Here we have, in red, our squaring function shifted b units to the right, even though it's negative. So let's figure out why that works. So let's go ahead and graph f of x equals x minus 2 squared. So let's go ahead and pick out some x values. Let's pick out the values we used last time. So when x is negative 2, 0, sorry, negative 1, 0, 1, and 2. Let's try those values to start. So I go ahead and substitute. So when x is negative 2, I have negative 2 minus 2 squared. Well, negative 2 minus 2, that's going to give me a negative 4 squared, which is 16. That's off my graph. Okay, let's try again. So if I take negative 1 minus 2, that's going to give me a negative 3 squared, which is 9. Okay, again, not on my graph paper. So let's go ahead and try this with 0. If I take 0 minus 2, that's going to be a negative 2 squared, which gives me 4. If I take 1 minus 2, that's going to give me a negative 1 squared, which is 1. And if I have 2 minus 2, that's going to give me 0 squared, which is just 0. Let's go ahead and plot the points that I have found that are on my graph. So we'll plot these 3. So when x is 0, y is 4. When x is 1, y is 1. And when x is 2, y is 0. Now, it kind of looks like I have the left-hand side of a parabola, but we're really missing that symmetry. So why don't we find a couple more values of y when x is 3. And to see if that's going to give us our symmetry. So if I take 3 minus 2, oh, that's an ugly 3, sorry guys. 3 minus 2 squared, that gives me 1 squared, which is just 1. Look, that matches our x value when x equaled 1, right? X equals 1, y equals 1. So here we have our symmetry. That means that the point when x is 2 and y is 0 is my vertex. So we can go ahead and draw on our parabola. Ooh, hopefully you can draw your parabola a little bit neater than I can.